Hello, everyone. We are in Unit 11.2 continued. The last video we did, we had looked at areas of compound figures, and we looked a bit at area of shaded regions and plane figures. But what's different there is that we did not include circles. So what I wanted to do here is to go back and to include some circles and find some areas of shaded regions as well. Okay, so let's just recall from topic 10 the formulas for circle area and circle circumference. We all know that the area of a circle is given by the formula area equals pi r squared, where a is the area and r is the radius of the circle. And for circumference, which, by the way, we know for polygons, the distance around a polygon is called the perimeter. Well, the distance around a circle we know is called the circumference, but we could also call that its perimeter as well. So the circumference of a circle is given by the formula c is equal to pi times the diameter, where the circumference is where c is the circumference and d is the diameter of the circle, or by the formula c is equal to 2 pi r, where c is the circumference and r is the radius of the circle. Okay, so we're going to look first of all at some relatively simple diagrams here, where we're going to find the exact shaded area in each figure in A through C. And then for the diagram on the second page of this note guide, we'll actually also be looking at not just the area, but also the perimeter of the shaded region. Okay. Now, for these first three, A through C, we're going to be looking at the exact shaded area, which means we want our answers in terms of pi. So we're not going to use the pi button on the calculator to get to a decimal. We are going to just leave the answer in terms of pi. Okay. So here for part A, we're going to notice that we want the shaded region, and we've got one circle inside another circle. Remember before, when we were doing areas of shaded regions in the prior video, we had subtracted one area from another area, and we're going to do the same thing here. Okay, so it makes sense to get the area of the shaded region. We're going to take the area of the large circle, and we're going to subtract the area of the small circle. Okay, and we know that the area formula for a circle is pi r squared. So we notice that for the large circle, the radius is 12 centimeters. And for the small circle, notice that we're actually given the diameter here. So the radius of the small circle is actually 4 centimeters, half of 8. Okay, so those are the values we're going to substitute. So for the area of the large, we're going to say pi times the radius squared, so pi times 12 squared. The area of the small, we're going to say pi times 4 squared. Okay, and then we're going to say 12 squared is 144 times pi minus 4 squared is 16 times pi. And if we subtract 144 minus 16, we will get 128 pi. Remember, we are always going to write units here, and because this is area, it's square units, so we'll say 128 pi centimeters squared is the area of the shaded region. Again, we're leaving it in terms of pi because we're going to get an exact answer. Okay, moving on to part B. Okay, now you'll notice if you look really, really closely, your eyes are mostly better than mine. If you notice here, you can see that there's like, maybe you can, if you look really carefully, there's a little space here between the circle and the square. Well, that space, let's just ignore, okay? So we're going to assume that the circle touches the square, okay? So just ignore this space in here. Right, let's just, you can kind of, if you wanted to, you can kind of just, draw it so it looks like, in the same thing on the top here. The circle is actually touching the square. Okay. So if I want to figure out what the shaded area is, you can imagine I've got a square here, and if I take away the hole in the middle, which is the circle, I'll have the shaded region that's left. So the area of the shaded here is going to equal the area of the square minus the area of the circle, okay? So we can see the length of the side of the square is 8, and of course we know that if this side is 8, either one of these sides is 8 as well, right? And so we can just say the area of the square is just 8 times 8, right? Side times side. The area of the circle is pi r squared. Well, we're going to, this should have been a subtraction, I'll fix that. So we're going to subtract the area of the circle, so I need to consider the radius of the circle. Remember, of course, if the diameter of the circle is 8, and by the way, we know that the diameter of the circle is 8 because watch, okay? If the side of the square is 8, I can draw a diameter parallel to that side of the square, so that diameter is also going to be 8 units. And if the diameter is 8 units, the radius is 4 units, okay? So I can say 8 squared minus pi r squared, or pi times 4 squared. And so I can say we've got 64 minus 16 pi. And since this is area and I'm giving you for units, I'm going to say unit squared. And I might put this in parentheses just so we're clear we're talking about that entire expression in square units. Okay? And we can't do any more because we have unlike terms, right? If we have pi in a term and we don't have pi, it's just like having x in a term and not having x. Unlike terms, so this is completely simplified. Okay. All right, so let's move on to part C. So maybe if you want, this would be a time, I want to remind you again, you know, you could pause the video and try to do this one on your own and then wait for me to work it out. So that way you can feel confident that you can do these types of problems. Okay, so maybe you already tried, maybe you paused and you already tried this. Let's move on. We know that the area of the shaded here has to be the area of the large circle minus the area of the small circle, okay? Now, the radius of the large is going to be 7 inches. The radius of the small is going to be 3 inches. So this one's really straightforward. We're just going to say pi times radius of large squared minus pi times radius of small squared. Okay? And so all I'm going to say is 49 pi minus 9 pi gives me 40 pi inches squared. That would be part C. Okay? So for all of these, remember that we wanted exact answers in terms of pi. In part D, we'll find the area and the perimeter. And actually, I'm going to change this. We'll do this to the nearest tenth. I think it'll be a little bit easier than the nearest hundredth. Okay. On your copy, I'll make sure when I post it to type the nearest tenth there. Okay. So note that ACEF is a trapezoid. Okay. So when we're saying ACEF, we're talking about this figure here. That's a trapezoid, and BCDH is a rhombus. Okay? So BCDH, we're talking about this figure here. It's always good to have those highlighters nearby so you can highlight as I'm highlighting. Okay? So there's our rhombus. Okay? And what we're looking for here is the area of the shaded region. So again, think about this before I actually work it out. Maybe pause the video. Think about recognizing we've got a trapezoid here, we've got some cutouts. We have a rhombus cutout, and we have a semicircle cutout. So what could I do to figure out what the area is of the shaded region? Okay, that's what you should be thinking about. You know, what could I do to figure that out? Okay, so hopefully you thought about it and paused for a moment. So we're going to say that the area of the shaded is going to equal the area of the trapezoid minus the area of the rhombus and semicircle combined. So we're going to take the area of the semicircle, which is of course a half circle, plus the area of the rhombus, and we're going to subtract it from the area of the trapezoid. Okay? And so for the area of the trapezoid, we know the formula is going to be 1/2 base 1 plus base 2 times the height. And let's think about the area of a semicircle before we fill it in, okay? So if we think about this logically, right? Let's go off to the side here for a moment. I know that the area of a circle is pi r squared, right? So the area of a semicircle, which is half of that, would be 1/2 of pi r squared, okay? So I'm going to say 1/2 of pi r squared for the area of the semicircle. And remember, for the area of a rhombus, if you go back to the note guide for 11 to, or actually it might have been 11.1, just check that first page of the note guide that you got right before the break. And you'll notice that for a rhombus, depending on your given information, you'll use different formulas. So for example, in this particular case, if you look at this rhombus, we're given a base and we're given a height. And so we can treat it as if it were a parallelogram. And we know a rhombus is a type of parallelogram with 4 congruent sides. In fact, I can mark those congruent to remind myself that those are all the same length. In other situations, I might figure out what the diagonals are if I had them and use the formula 1/2 of diagonal 1 times diagonal 2. But in this case, I don't have diagonals, I have the base and the height, and so that's what I'm going to use. Okay, so I'll say plus base times height. So I've already filled in values of the base and the height. As far as the radius for the semicircle, let's look over here. This distance 7 is the diameter of the semicircle. Okay, so for the radius, it's going to be half of that, which is 3.5 centimeters. Okay, so now I have the radius. As far as base 1 and base 2 of the trapezoid, for the two sides of the two bases of the trapezoid, it doesn't matter which one I call base 1 or base 2. I'll go ahead and I'll call the shorter base base 1. And I'll call the longer base base 2. Now we can see that base 1 is 7 centimeters. Base 2 is 11 plus 5, or 16 centimeters. Okay, so now I have all the values that I need to calculate the area of the shaded region. I just need to substitute. So base 1 is 7. Base 2 is 16. The height, now let's be careful here. Okay, the height of the trapezoid is not the same as the height of the rhombus. So be really careful which, the values of h here are different. So in fact, I'll highlight that so that we're very clear which value of h I'm using. So here, this value of h is for the rhombus, okay? And now for the value of h over here, this is the value of h for the trapezoid. So that's a different h that I'm looking at there, okay? And so the height that I want to use here for the trapezoid is 10 centimeters. Be very careful with that. Then I've got 1/2 of pi times the radius, we have already got there, is 3.5 squared, plus the base of the rhombus is 5, and the height of the rhombus is 4. Okay, So now I've got a lot of information in here and I have to make sure I do the correct order of operations and simplify this correctly, okay? So I've got 1/2, I'm gonna say 7 and 16 is 23 times 10 minus 1/2 of pi. Now at this point I'd use my calculator for time saving. I went ahead and I already calculated that and I got 12.25. And over here, 5 times 4 is 20. Okay? So again, make sure you're doing the correct order of operations. I'm going to multiply here. Now I'm going to do 230, or 23 times 10 is 230. 1/2 of that is 115. Over here, okay, I'm going to take 1/2 of 12 1/4. Now 1/2 of 12 1/4 is 6 1/8, or 6.125 times pi plus 20. Okay, now here, this is where I'd use the pi button. So go ahead, remember on your calculator here, the pi button is right here. So when you're working this out, use that pi button. So I've got 115 minus 6.125 times that pi button is going to give me 19 points. Let me go ahead and show you what happens here. So we got 6.125 times pi equals, I get this 19.242255. And I'm going to round to like 3 decimal places. So I've got 19.242, and I'll say plus 20. Okay, I don't want to, in the very end here, I told you we could round to the nearest tenth, but I don't want to round to the nearest tenth at this point. So I want to be, go out a little bit more so I have accuracy. Okay, so I'm saying 115 minus, and I'll add these two together. So I'll get 39.242, and I'll subtract 115 minus that value. So let's do that. So I have 115 minus 39.242 equals, and I'm going to go, like I said, we can round to the nearest tenth. So I'm going to say that this is 75.8 square centimeters. Okay, so that's the area of the shaded region. Okay, so that's the area of the shaded. Okay, now finally, the last thing I want you to do on this one is I want you to calculate the perimeter of the shaded region. Okay, so let's look at that carefully and figure out what's the perimeter of the shaded region that I'm looking for. So let's highlight that. Okay, so perimeter is what I'm looking for here. That's the distance around on the edge of the shaded region. Right here. Okay. Oh, sorry, right here. Not this part up here. Let me just wipe that out. Okay, so we're not looking at up here. We're just right here. This pink part right here is what we're looking for. Okay. So I'm just going to, I'll fill in the rest of what I had up here. Fill in the trapezoid. There we go. All right, so we're looking at just this pink area here. Now, some of the things you want to notice, if I want the distance around, I've got this piece here. That piece is 11, right? So let's highlight all the pieces that we're looking for because it gets complicated. So I know I've got that 11 right here. That's that distance. Now right here, I've got this length, but I know that all 4 of these sides are congruent. So if this side is 5, then this side is 5 centimeters. And this side is 5 centimeters. So now I've been able to figure out the lengths of the 2 pieces here. Okay, so I'm going to circle those and I'll highlight. Okay, and then over here, This piece you can see is 6 centimeters, and I'll highlight that. And this piece over here, well, let's figure out what this piece over here is, okay? So this is a trapezoid. We know that these two sides are parallel, which means that these two sides, the legs of the trapezoid here, are going to be, we know that these two sides are going to be congruent. So we've got that 6 and 4 here, or excuse me, 6 and 5. This is 5 right here, right? So 6 and 5 are 11, so this side is also going to be 11. Okay. And so I've got all the pieces here except for one piece. So I've got this piece, this piece, this piece, this piece, this piece, but the only piece I don't have is the length of this semicircle, okay? Which is basically the length of arc FGE. So let's work that out, all right? So let's write what we've got so far for this perimeter. So I've got 11 plus 11, okay? We'll just kind of go around the figure. 11 plus 11 plus 5 plus 5 plus 6. So 11 plus 11 plus 5 plus 5 plus 6 plus the length of arc FGE. Okay, so we just need to figure out the length of arc FGE, right? But think about this logically. What you have here is a semicircle. So if I continued that around, the distance all around would be the circumference. And remember, we were talking about at the beginning here that when we're talking about perimeter in terms of a circle, we're talking about its circumference. And so we're really just looking at half of the circumference of this circle, okay? Now, if we were looking at it, you know, in terms of the way we looked at this in topic 10, basically you're looking for the arc length of arc FGE. And if you go halfway around the circle, you're going 180 degrees out of the 360 degrees. So, you know, we can kind of put a note on the side. You wouldn't have to really do all this work, but just to kind of relate it to what we've done before, we're just basically taking 180 degrees out of 360 and times the circumference of the circle, which is pi times the diameter, okay? Remember the formula from topic 10, n over 360 degrees, we either had times pi d or times 2 pi r, and that gave us arc length, okay? So basically here, you know, in simpler terms, we're really just saying we have half the circle. So we can just say half of the circumference, half of pi times the diameter, which is 7 centimeters, okay? And so we're just saying half of 7, which is 3.5 times pi. So that's that arc length. And that's what we're going to just add in here to be able to get the distance around the shaded region, the perimeter of the shaded region, okay? So I basically am going to say add these terms up, okay? So if I add those terms up, if you add those up, you'll get 11 and 11 is 22, and 10 is 32, plus 6 is 38, plus 3.5 times pi. Okay, now in this case, again, I'm rounding to the nearest tenth. I'm not going to leave this in terms of pi. So I have 38, and if you work this out on your calculator, you'll get 10.99557 and so on. And if I add that together, I'll get 48.99557. But I want to round this to the nearest tenth. So this gives us a little practice as far as rounding to the nearest tenth. You want to be really careful, right? So if we round to the nearest tenth here, you'll notice that we have in the tenths place a 9. So that has to go up to 10. So we end up with a 0 in this place. And we bring that 1 back over here. So we end up with 49.0 centimeters to the nearest tenth, and that would be the perimeter. Okay? So just to review, because there was a lot to this here. On this last one here, we calculated the area and then we calculated the perimeter. Calculating the area, we took the area of the trapezoid and we took away the area of the rhombus and the semicircle. Then we calculated the perimeter, which is highlighted in pink. And we calculated the perimeter including this arc, which is a semicircle, which is half of the circumference of the circle with a radius of 3.5 centimeters. Okay? All right, so that finishes up section 11.2. Thanks, have a good day.